I can't remember the number. I said it last time.
Yeah, we should write that down.
Lead sharp number, it's an impressive number, 157 I'll say.
Sounds good.
Yeah, we've been going for 8 years, so and we've never missed the lead sharp, that's good. Even when we were 2 people, remember that? In the beginning. It's great to see all you here, lots of familiar faces, and we've got a great talk lined up for you, and we've got a couple of things to go through first.
Yeah, so do you want to mention the sponsors?
Yeah.
The lovely people from Fruition, wave your hands in the air.
Yeah.
She is there, she sponsors the beer. Thank Fran for the beer.
Fran's great.
We love Fran, we love Fruition IT, thank you.
She will also improve your salary.
Jobs prospects, ask her in the pub afterwards.
Yeah, ask in the pub afterwards. Great. I'll just say what you say.
Yes. It's like an echo in the room.
So we'd like to, we just mentioned the meetups we've got coming up. So in September, we've got Monolith to microservices using Azure Functions and API Management Gateway. And I think we're covering C#8.
C#8 as
We've
well,
got a spot.
We've got a double whammy coming up.
Yeah, so that's going to be a really good one.
Yeah.
Has anybody looked at C#8 yet? Great.
Yeah? Anyone using it in production? No? It's not out, yeah, that's why.
So that's going to be really good. And then in October, we've got machine learning with ML.NET and Azure.
Yeah,
We've got
another good one.
Yeah, Andy Cross from London, an Azure MVP, coming up to give that talk. Really top guy, really nice guy. Okay, luckily, a bit of a slow month for news, so we're going to skip news, you'll be glad to hear. So we'd just like to introduce our fantastic speaker for tonight, Ian Cooper. So, based in London, founder of London.NET User Group. Is it Ludnug? Is that who?
LDNUG, yeah.
LDNUG.
We share it with a group in Dallas. We did have an incident once when people turned up in Dallas for our meeting, which was a little bit embarrassing.
Brilliant. Microsoft MVP 15 times over?
I think so, yeah.
Yeah.
Golf club?
So we're in a company of a MVP veteran.
Yes.
So thank you.
I still don't know how it works.
And just doing a little bit of research, I came across a talk he did last year. TD talk.
TD, where did it all go wrong?
Exactly, yeah. And Robert Martin, Uncle Bob, described it, if you don't mind me mentioning, as this talk is one of the best I've seen in a decade. Watch every second. So, high praise indeed. And it is a really good talk. So
we just want to set expectations.
Yeah.
This talk isn't as good. Okay?
We'll put a link in the comments afterwards. So anything that we cover, we'll put a link in. And you're the founder of the Brighter Command, the NuGet packages.
So Brighter, which basically is a CQRS and tasking machine library. We'll see it tonight.
Yeah. So you remember we mentioned CQRS last week. I mean, just give us a reminder, who uses CQRS in their development? Great. Who wants to know more about CQRS? Cool.
Who wants a library that just makes it all easy, goes away, the pain goes away?
And finally, apparently a tabletop gamer?
I am, yeah.
What kind of games?
Wow. I nowadays play a lot of what they tend to call story games, so Hero Quest, a whole lot of Powered by the Apocalypse games, Monster Hearts and Apocalypse World, etc. Yeah, occasionally I foray back into the world of D&D because it's popular again. Turns out basically if you put good-looking people on YouTube, D&D becomes really popular.
Yeah. Any other tabletop gamers?
Hey!
Does exploding kittens count?
Cool. So, over to you.
Cool, thanks guys. I'm just going to grab a cable.
Oh, we should be mentioning we're having a pizza break halfway through. Our pizza order got cancelled 15 minutes before we were due to start, so we'll have to go down there, grab some pizza and then come straight back again. Sorry about that.
apologise for the small monitor as well. We're we used to be on the 10th floor. We had a big projector. We're trying to sort it out. We might be in a different venue next month. Clearly not big enough.
We'll make it all work.
All right.
It's okay.
Oh, and one last thing. Definitely one last thing. We did get some stickers and some pin badges from Elmar.io, so if anybody wants any stickers, just these kind of things, then just come and see me and we'll dish them out.
Thank you very much. I've got some stickers.
We I don't have any with me, so I don't know what I'm telling you. But we for Bright we produced some stickers, and it's really hard to get traction with an open source project in, say, the US if you're European and UK based kind of like team working on it. And we've been trying to get Hanselman to basically mention us on his blog post for ages. And we got stickers, and I put a picture of stickers saying, we got stickers, things have really happened to us now. And then Hanselman basically blogged about us. It was kind of like, if only we'd known stickers was the answer.
I have a very crumpled one, Ian, if you want to give it away.
Wow, you crumpled my sticker. Why isn't it on your laptop?
It's on my laptop as well.
All right. Who has heard anything about 12-factor apps beforehand? Okay, is that because you read the premise for this talk, or because people were bugging you about what 12-factor apps sort of thing? You're northerners, you're allowed to speak. It's usually down south where people sit in silence.
So I used to play around with Ruby and
Okay. Heroku.
Yeah, exactly.
Yeah.
So that's where I come from.
Is anyone actually, working with someone where they basically are encouraging you to try and approach 12 factors or anything like that? Or and who's heard about it in the context of cloud native? Who knows what who's heard of cloud native? Okay. All right. It's like all these memes. It's sometimes just a question of figuring out. You heard this meme or not, right? It's just not a meme, it's a set of ideas. It's quite a useful collection of ideas. It's been around for quite a while, and we'll talk about the context has become more popular in recent. For most of that got mentioned. The only point I ever pull is the one on the bottom of the slide deck. This isn't going to do those points for me. So I encourage everyone to try and speak. It's very good for you. It helps you organise your own thoughts and makes you delve more deeply into a topic that you may think you may understand in order to better present on it, because really you are the content, not the slide deck. I got started almost by accident. When I started the .NET user group, I was a C++ developer. .NET was a whole new thing. Some people in the US were going to meetup groups discussing the beta. I put a post on the mailing list saying, when is the London group meeting? Really excited. And it was like a desert, and then someone mailed back and said, if you start it, I'll come. Which was kind of a bit of a challenge, a bit field of dreams. So, and early on, there were really no speakers, because even Microsoft didn't really have many .NET experts. So we literally had to be, as a community, self-organising and speak ourselves. And a lot of people who you may see out on circuit today, that's essentially how they started. They just started talking at the local user group about stuff that they had discovered and wanted to share with everybody else. And then it just goes on, right? Once you get more confident at speaking in front of an audience and you get over that nerves and you realise in tech, no one actually wants you to be, unless you are a god, some really professional speaker who's done tons of speaker training and is really good at that kind of stuff. They just want your content and your ideas. I'd really encourage you to do it. Start somewhere like here, do a lightning talk. I've been an MVP for 15 years. You probably ought to be knocking me off that pedestal at some point. Right? Okay, that's where I work, Huddle. Nothing really to say apart from I'm not a consultant. I have nothing to sell you. Right? That's Bright, which I work on, which is an open source product. You'll see it'll be used in some of the demos for simplicity. It does two main things. So one is, we also got a sister product, Darker, that goes with it. In a CQRS environment, it does essentially Bright does the command side. So basically you get a command, dispatches it to a handler. We also have a query side, Darker, which basically takes a query and dispatches that to a handler. Right? We also, that's not our, things like Mediator do that as well, but it's not particularly our secret source. So our secret source is we also then, as well as posting that in process, in memory, we'll stick it out over message-oriented middleware over a queue, and you can handle it in a separate service. You'll see us do that tonight. So you basically can offload work, right? And we support a number of transports. Our biggest transport for today in terms of support is Rabbit and Q. We also do have a pretty good working Redis transport. I'm just rewriting our Amazon transport because it's a bit crap. It hasn't taken advantage basically of lots of improvements in the Amazon client over the last couple of years. And our Azure client needs some love from somebody who does Azure. I don't do Azure, we don't hardly anyone working on that does Azure. We'd love for someone to come along and say, I will take on the Azure transport and do some work on it. One for Kafka as well. Right, okay. That's what we're going to talk about tonight. So I'll talk a little bit about the context of 12-factor apps as a meme and idea. Why has it suddenly come into vogue? People start mentioning this idea of 12-factor apps, right? Talk about its origins, where it came from. I think someone's already kind of mentioned that a little bit over there, just to give a nod to the guys who came behind it. Talk about the goals. Why would you essentially want to take the principles that 12-factor apps describes and employ them in your development practice? What would you going to get out of it? Right. Then we'll talk about what 12 factors are. Now, when I first decided to do this talk, one of the things I did was decide, I'm just going to run through every one of the factors in turn and tell you about them. And there are 12 factors. Obviously, it doesn't give you very long for each factor if you want to talk for only about an hour, so I don't do that anymore. And nowadays what I do is say there are three main groups of factors: design, build, release, and manage. We pick out some of the key ideas in those areas from 12 factors. And at the end, we'll talk about the factors again and show you how it all kind of ties together. So pick out some key ones. We'll talk about 6 or 7 in detail, and then we'll mention the others more in abstract, because a lot of them are blindingly obvious. Okay. Right. So you can download the slide deck and you can download the code. So those of you sitting at the back or struggling to see this small screen can find out what it was all about afterwards. Feel free to take a screenshot or so. Essentially, you can just wander over to my GitHub account, Ian Cooper, and there's a section called presentations and one called 12-factor tutorial. It's fairly obvious to find stuff. There's other presentation slide decks in there. I recommend against trying to sync that particular directory down to your local, because it included video and stuff at some point, and so it's huge because GitHub remembers everything. Just GitHub's nice though for PowerPoint stuff. Just let you download that binary content directly. So just use that approach. Okay. You can ignore that. Right. Context. Why should you care? Okay. So there's an idea doing the round, particularly pushed by a consultancy called Pivotal. Anyone work for Pivotal before I say anything? Okay. So, Pivotal are one of those consultancies that basically push a lot of this is how you work today, agile models, etc. They're kind of where ThoughtWorks were kind of in the 90s, 2000s. And if you go out to the West Coast, people talk about the Pivotal way, that kind of etc. So they're quite influential. And Pivotal essentially bang on about this idea called cloud native, and it's even reached this idea there's a thing called the Cloud Native Foundation now, where Kubernetes lives along with a number of other basically bits and pieces of kit, kind of open source foundation. And when they talk about cloud native, one of the things they say is that one of the pillars of cloud native is 12-factor. What the others are, okay. So an obvious question might be, what is cloud native, right? What do we mean by this idea that you should be building cloud native applications? Okay. And a question maybe we want to ask ourselves in order to understand that is, what do we think we mean by cloud? Anyone want to give me a definition of cloud? What do they think cloud is?
Infrastructure as a service.
So again?
Infrastructure as a service.
Infrastructure as a service is not a bad one. Any other potential definitions? There are no wrong answers, sorry. Yeah, there's always one, how it comes out with that one. I should have a prize I should give away to the person that basically says other people's computers. Anything else?
Not on premise.
Not on premise, that's not a bad one. Okay. There's something about the nature of cloud that is significant, right?
Networked.
Maybe. So some of it is to do with if I'm essentially, there are some things like capex versus opex expenditure. Basically, that means anything to you. In other words, essentially, if I'm a startup, effectively, I don't have to put capital expenditure into buying kit and putting it in a data center. I can essentially begin putting out my service effectively with a small upfront investment and pay the bill afterwards, right? So it's basically it becomes an operational expenditure, which is why, in a sense, there's lots of popularity around it from the startup community. But there's a key thing that cloud does that basically we don't get in other sense. So if I have a data center, who's been to a data center?
Loads.
So it's like I think there may be an age divide in the room. Okay. For those of you who've never been to data centers, have you seen pictures of what data centers look like? Right? Big racks of machines, right? And traditionally what happens is, in the kind of data center world, is I say, my business is going really well, right? We seem to be getting basically thousands more customers joining up to our viral program. And my boss says, wow, the servers are really coming under strain. We're going to need to expand our capacity. And I say, you're absolutely right. So what you had to do is you get on the phone to the data center and you say, oh, we'd like to buy a new machine, right? You need to increase our capacity. And they go, fantastic, that's really great. So after you and the lawyers exchange a few contracts and spend quite a week or so trying to buy this one Dell machine to stick in your rack, and you basically signed 20 pieces of paperwork, they say, fine, we'll get that in for you then, right? So that gets shipped in and arrives about 6 weeks later, and it comes on basically someone, on a forklift, on a pallet, right? And they finally load it up into your rack. So about 8 weeks have passed, and you're saying, fantastic, our new machine is here, this is going to be great. And then they say, we've got to provision it first. It's got, put the operating system on it, blah, blah, blah. So you have to raise tickets and get it all fixed up. And then basically probably about after 3 months, you've got your new capacity, right? It wasn't much good to you if your viral marketing campaign had exploded and was bringing you in, Pinterest numbers in terms of thousands of users basically signing up per day, because it's taking you 12 weeks to provision the kit. So one of the key ideas basically behind cloud is it's basically an on-demand elastic environment. In other words, I can essentially choose to spin up new resources with very little effort when I need them. Okay. That's a kind of official definition by somebody. Matt Stone, it was pivotal. Okay. So a cloud-native app is obviously an app which is designed to run in the cloud, but more particularly, it's an application that allows that environment to be exploited. Okay? And by that we mean an elastic on-demand environment. Right? So we're running an environment where we expect to be able to essentially scale up or scale down very quickly. So there's a maturity model, because all things must have a maturity model. Don't worry that you can't read this. There may be a benefit to you in not being able to read the maturity model. But they have kind of cloud-ready, friendly, resilient, and native. And to be honest with you, I'm never sure. They've got microservices and API first designed down in native, and I'm not sure that's not just something you do anyway, right? Even if you're in a data center, why wouldn't that be appropriate? But in terms of ready, friendly, resilient, they're talking on ready. They're talking about saying, don't access the disk. Let the platform manage the ports and networking, and then the friendly is what 12-factor apps here, horizontal scaling, leveraging platform, and then the resilient we start talking about fault tolerance, basically talking get to Chaos Monkey and Netflix and that kind of stuff, right? So 12-factor apps basically are one of the things that people are saying you should really pass your way through this particular gate on the way to becoming a application which is going to benefit from running in the cloud. Even if you are in data centers today and you're local and you're not on cloud, actually my proposition would be that much of the advice given to you today on cloud does have a relevance if you begin to run in things like containerized environments like Docker or Kubernetes. Because often you're actually trying to do the same thing, which is essentially take a fixed pool of infrastructure that you own and essentially optimize delivery across it. And even on the cloud nowadays, what people are deploying effectively to the cloud with containers increasingly. So much of the guidance that essentially is cloud native is also, I think, container native. Again, the kind of goal effectively is to have essentially elastic on-demand resources, maximize our use of resources by scheduling in order basically to control our operational costs. I want to talk about costs. That's important, right? To talk about things like costs, even as devs, because the way that you get your bosses to do useful things that you want to do as an engineer is you talk about what is the bottom line from their point of view, right? Why would I basically say to you should go to Kubernetes, right? Why would your boss care? You care because generally the average in the industry is there's a 50% reduction on your infrastructure costs in cloud. Most of your cloud compute is actually doing nothing, and even if you set CloudWatch alarms to bring resources up and down, essentially a lot of it is unoccupied, and you can schedule better by treating it as a pool over which effectively a decent scheduler basically puts processes. Sure. Right. So 12 factors is good for containers as well as cloud. The key thing to remember is essentially the reason you care about 12 factor is because you care about an elastic on-demand computing environment. Okay. If you say to me, Ian, basically we have 40 users and that number is never going to increase, that's the size of the department, perhaps basically in 6 months' time they make up to headcount at 45, you may not care. However, I think that they are probably good practices for maintenance anyway of your code. They're not necessarily aimed at that environment, but they are still useful practices. You may want to cherry pick some of them. Okay. So someone mentioning earlier, it comes from Heroku. So Heroku was originally a Rails cloud platform. It increasingly became a PaaS platform, which was tried to move away from its tie to Rails. And there's a guy there, one of the co-founders, Adam Wiggins. And what Adam did was, he doesn't work there anymore, he works for, I think, some sort of Y Combinator in Berlin. He did this analysis where they looked at all the apps that were running on Heroku and said who succeeds and who fails, and why do they succeed and why do they fail on Heroku as a platform. And as a result of that, he came up with this guidance list called 12-factor apps, which he blogged about, saying this is what we at Heroku see as the people that are successful are doing to basically run their apps here. Okay. So these are the 12 factors. I'm not going to read them out to you because we'll run through key ones as we go. But what you can read what I'm talking. But what I really wanted to draw attention to was I kind of bracket them into 3 groups, which is kind of where we're color coding, right? So there's a whole load of stuff which really is in green, which is about, I would say, design time, right? This affects how do I design my application when I'm thinking about the architecture of it. And we'll tackle those kind of first as a discussion. So there's discussion on design. Then there's a section basically which is in red, which is really about operating or running basically our code, things that effectively impact the way that we choose to do that. And there's some stuff in blue, which is really about how we run our CI kind of CD platform, how we basically build and deploy our code. Okay, so we'll try and take them in a logical order: design, build, and then run, and we'll talk about the different factors. Okay. Design. Okay, port binding. Right. So the first rule, basically, your app is that you should export your service by port binding. Okay, what does that actually mean? So there's a really easy way of thinking. Who's played .NET Core? Right. So when you play .NET Core and you've got an app, who's running in something like Kestrel? Right. Okay. So you run it in Kestrel, and what happens is essentially you're spinning up a self-contained service that says I'm going to listen on a port or a range of ports. Right, and we're going to listen for HTTP. I think the default on Kestrel is like 5,000. Okay, so basically you spin up Kestrel and it says I'm going to listen on port 5,000. Right, it's essentially exposing itself on port 5,000. It can receive or service requests on that port. Okay. When we actually deploy that to infrastructure out, we might stick something like Nginx in front of it. We may actually say Nginx is going to listen on port 80 and it's going to proxy basically requests onto port 5,000. But the infrastructure is essentially managing the ports for us, but we simply expose ourselves as a port, and then we can essentially be deployed into an environment where effectively people can redirect to us. Right? We just expose a port. Doesn't have to be HTTP. You can bind ports to do other things if you want to listen to messages. So you may be using, for example, the MQP protocol, and you're probably listening on port 5672. Right? But the idea is essentially you say, I want a standalone service whose interaction with the outside world is either I listen on a port or I receive on a port. one of the interesting things is who's built any kind of service application, Lambda, Azure functions, that kind of thing. Right, one of the things you're doing there quite often is you're just basically building something that listens on a port, right? So it's a key kind of principle of this kind of model, saying I'm building stuff that listens on a port. Okay. One of the key ideas basically is you should be self-hosted. Okay. So your app itself should just spin up when it starts and start saying, okay, I'm now listening on a port, send me some traffic. Okay. And you can talk to other apps at that point because those apps effectively also have a port. So everything you want to talk to, you should address by having a port. And obviously, there's probably a URL of some sort or a URN, where effectively you've got some other address plus the port. Okay. Let's put that a second. Okay. But one of the key ideas basically is avoid something like IAS, like the plague. All right, let's talk about why. This is IAS. You've seen this kind of diagram before. Who knows how fantastic way that IAS works? Okay, so basically with IAS, a request comes in off the internet, hits the HTTP sys stack basically, and that then launches the Windows Activation Service. The Windows Activation Service says, I need to find something that basically deals with HTTP requests of this sort. So it goes away basically to the application host config, and it says, find me something that's registered to deal with basically this particular HTTP request. And that leads you to the Web Publishing Service. The Web Publishing Service basically briefly talks to HTTP service, says, yes, this is who talks to it, and then goes away and spins up basically something like a W3P worker process to go and service your requests. And IIS can essentially launch a whole range basically of worker processes. So effectively it can do web garden arrangements where effectively you have multiple things on the same box where effectively you're running on separate threads to service your request. It can also effectively talk to other IIS instances, saying, okay, let's basically all talk together on the web farm. And essentially you commonly have a model where your IIS server effectively says, I am going to serve, 5 or 6 apps as part of your service. Here's your API endpoint, here's your basically web endpoint, etc. Right? Who's got some set that looks a bit like that today? None of you? None of you using IIS? Okay, all of you. I think maybe I should just go home while he explains to me exactly how you've all got it all working. Okay, right. So what's something else? Docker. Who's familiar with Docker? You can be smart and say I'm familiar with Kubernetes. Docker is old hat to me if you want, but that's fine. So here's what happened with Docker, right? So Docker basically you have a Docker host which is running a Docker daemon, right? So typically it's a Unix box. Even if you're running essentially Docker for Windows, typically it's actually a Unix box in a virtual machine on your Windows box that effectively is doing the work. And the Docker daemon essentially is a process that just runs and says, I've got an API that you can call me. And so your Docker client, so the command line or whatever, effectively just essentially issues commands to the API in the box. Basically just says, I'm going to call the REST API, the Docker daemon running in the box and tell it to do stuff. Right? And typically what you're doing is you're spinning up a container, right? And all that happens is I say, hey, Docker daemon container. So it goes, creates the registry, pulls down some images, and effectively, etc., and then runs them, right? And the thing to understand about a Docker container is it's not a virtual machine, it's basically a sandboxed process. Okay, so just a whole set of processes running on the host, but they're sandboxed from each other, so by namespacing, so they can't actually damage each other when they go wrong, or if they go wrong, right? Unless they create some kind of kernel panic which takes the whole host machine. The interesting thing here to understand though, right, is when I get into this kind of environment, I have something that essentially is sandboxing processes for me that are therefore running and sharing over resource. It makes bugger all sense to be running IIS inside one of those containers. Because then I've got a container technology running inside a container technology. And this container technology doesn't offer me sandboxing. It doesn't offer me basically the fact that if one of these goes wrong, it's not going to basically trash something else running on the same box. Right? This gives you much more warm fuzzies, provided basically the problem is going to be in user space rather than in kernel space. So when we start thinking about how we're going to deploy, there really isn't any point in going for one of these. And don't worry, we're not just picking on IIS, picking on Tomcat, I'm picking all the Apache. So I'm an equal blame person. I will blame all parts of the stack. but you really don't want that anymore, right? So what you want to do is run a self-hosted application, hopefully that basically has some kind of lightweight HTTP and essentially is able to communicate with things like port 80. Probably farm out to something like Nginx or some other basically proxy to essentially do the heavy lifting around things like SSL termination, routing, gzip, all that kind of behavior, right? Backing service attached resources. Okay. Anyone know what a backing service is?
Dependency, basically.
Yeah, that's right. It's dependency. So anything that isn't essentially part of my code that's a resource that I depend on is effectively a backing service, right? So an obvious backing services would be, I don't know, I'm writing some site that effectively needs postcode information, and I make some call out to some provider that provides me with postcode lookup, right? It's a really obvious one, but a lot of things are also backing services, or database. Database is another obvious backing service you may think about. But actually, your file system is a backing service, right? Anything you talk to that essentially is provided to you is technically a backing service. And problem when you get to cloud or container environments is that some of the things where you may have just depended on it as a thing that exists and not really thought about it as a service is just not true anymore, right? Let's put a different question. So who knows kind of how cloud data centers work? Shipping containers and all that kind of thing, right? Magic. They do work by magic, Joe. Okay, so what happens basically effectively is I get a shipping container, and I put into that shipping container commodity hardware built somewhere like, Vietnam, cheap really machines. And those machines will fail, right? They're cheap. The mean time between failure is not even the kind of classic 3 years. It's completely the opposite. The stuff that's going to the dedicated rack space data center that you paid a lot of money for, right? And what happens is, when about half of the machines inside that shipping container have failed, they literally lift the container out of the data center, take it away, and try and salvage what they can at some salvage center. Which you just throw away. So one of the things to bear in mind is that the physical hardware that you are located on when you create an instance in a cloud environment will disappear. Right? You will be in an entirely different shipping container at some point in the same data center if you're lucky, 100 miles down the road if you're not. Okay? So if you decide that when you're in your app you're going to rely on the local file system on the machine, that's probably not going to last. Okay? There is really no way you can guarantee that any of the data on the local file system on the machine is going to last for you. You're probably going to lose that instance and spin up a new one, and any local data you had is gone. Same with a container, right? A container gives you an illusion of, I've got a file system where I can talk to it. But if the container vanishes, you lose all the contents of the files that went with it, right? So what you have to do in these environments is attach volumes, right? So you attach like an EBS basically within say S3 or S3 rather than AWS, so long-term storage or faster storage, then that provides you something that's more permanent, right? You say, well, that EBS is effectively where my data lives. Okay, or this S3 environment is where my data lives. That becomes a service that I'm now talking to, or different protocols, HTTP or TCP/IP, effectively, etc., to get my data in and out. If you're in Docker, basically, you set up a volume, effectively, which is on the host machine, or if you're in K8, you set up a volume, a different type of volume, right? So all that work effectively is saying, this is a service that I get provisioned for, and I can't depend on the local file system anymore. I can't depend on the cache on the machine, right? Because if the machine goes, so does the freaking memory, basically, that I was actually storing to locally on the machine. So I have to have some kind of distributed cache, like Redis or Elasticache, or whatever, etc., right? I need to have something outside my environment, so that you have to think of everything I depend on that is not part of my code as a service that has an address where I talk to it and needs to be provisioned. Okay. And it's surprising when you go and look at the average code base that you're thinking about moving into one of these environments, quite how used we got, basically, depending on the file system. If you look in a serverless environment, for example, serverless environments, where they tend to work is, I deploy my code, and what happens is it gets deployed to a kind of essentially a fleet of containers. And what will happen is Amazon will literally, in response to a request coming on that port, it will basically either create a new container instance, or if it's got one already, essentially may serve you an existing one. And some people try to get tricksy, right? So what they'll do is they'll peer at the container they've got and say, oh, is there any of our cache data on here? Well, there's not. Well, we'll download our cache data on. Maybe next time we'll get lucky and get one with the cache actually preloaded on it, right? Java guys particularly bad at this because Java is struggling in service environments because its runtime is expensive to start up. But you can't rely on that stuff, right? So you need to think about all these things that previously you may have taken for granted. There's a file system, there is memory that I can use. Anything that essentially is not part of your running process that you depend on needs to be a service that you communicate with. Okay. Ooh. I'm demoing already. Fantastically exciting.
Yeah. Yeah. We break in 5 minutes or after the demo, is that?
Demo's a little bit longer than 5 to the demo. Is that okay to
Yeah,
do demo and then break?
Yeah.
Okay. So I'm going to assume, because of the size, that anyone who's really fascinated by the in-depth working of the code is going to go away and look at it later. So I'm going to give you kind of highlights for you to understand what's going on. So this is the world's most over-engineered Hello World application. So what you can do is you can post a greeting to my service, and I will essentially let you retrieve those greetings. Because, you need to do that. Ignore worker. I just didn't want to do git clean in case there wasn't imagine it's not there. It's pretty empty, but the folder's there because I have downloaded for the next part. Right, okay. So greetings app and greetings core. So greetings core essentially just so that later on you'll see worker can effectively also use it. So the idea is that all my core libraries, my domain, everything else lives separately from the thing that's an interface for it. So I can have different types of interface, right? So the API is just one way of exposing that. I could have a console app if I wanted to, right? And within here, it's pretty much what you would expect from a controller, okay? I have some gets, I have some posts, etc., which take in my data, right? And my data that you see here effectively I find this is it's great for demoing stuff. This particular app code, but its IntelliSense breaks a lot. Okay, right. Ports. Okay. So it's using ports and adapters as a architectural pattern, and I tend to believe in expressing that in the code structure. Don't worry if you've never met that before. Really, all you care about to understand that is adapters a technology concern that talks to the outside world, does some I/O. Port is the bit that talks into the domain in the middle. That's what you need to know. But let me try and. Where is my model? Configuration controls. Yeah. Adapters. Right, so our greeting request is fairly straightforward, it's just a message that we're pumping in, right? And the add greetings control, when we go back to it, the only thing that you'll find in there is a little bit complicated that you may not kind of track is what we do is we say, take that greeting request and turn it into a command object, and that's really just kind of mapping between 2 different types. So a type that essentially Brighter expects and a type coming over the wire. And then this command processor send thing basically just says, find a handler for that's registered to deal with that kind of command. And the query processor is doing something very similar. So it's create a query basically, so it's going to use the GUID that effectively we get back from the creation statement. And it's saying, go and look up the data for it in the database. And I can just show you those handlers. So this is essentially what Writer and Docker do at a simple level, something Mediator does, which lets you essentially push these off to reusable handlers. And the idea effectively is that you could change the handler fairly easily. It's just a command pattern, separation of concerns. And this code in here is not particularly exciting. This is a typical Writer handler. It's just saying in here effectively create a entity framework context and then basically add that into the database, right? And then I think if we look at the query handler, we'll find that is very similar. Gosh, scrolling seems to be harder when you have zoomed in. It's like you feel like you're jumping the whole time. Greetings by ID handler. We have no real estate. Okay. Come on, you. But this is essentially it's actually the same thing you'd expect. It's an entity framework. We're essentially saying create a context and then find that ID, right? So there's been nothing there that's particularly challenging. It's just essentially a slightly different code structure. And we'll talk a little bit later. You'll see why that's actually can be useful. But one of the key things to understand in terms of the context of what we're talking about here is this. Right. Everyone's presumably seen one of these files before. Ignore the fact we're saying use IS integration. That's kind of irrelevant because we're not. But we're saying essentially here, here's basically my host. I'm self-hosting essentially with inside a console application. I'm going to listen on port 5000, right? Effectively, and then when I run, this thing will just spin up basically and start hosting. And to run this, we're essentially going to run it in Docker. We're just going to use that because it's easy. So you can see we've got a number of Docker files. There's one, essentially this Docker file effectively is just saying effectively download the base image, copy across our code. There are better ways of doing this. Since I wrote this demo, you can basically build it on one Docker image and then create the executable image from that. An entry point just says run this essentially as a sandbox process, and effectively you're just running this particular app, which is basically Greetings app DLL running in the .NET runtime, and just run that process within Docker. And generally within Docker, you want to effectively just run one process in a container. There are some exceptions where if you've got some kind of sidecar relationship. And then we're basically using Docker Compose to spin it up and spin up basically a database as well, right? And we're just using MySQL here because if you use SQL Server, it uses all the memory in your machine. And my demo would basically die. We're using environment variables here, clock that, but I'll not explain that till later. We've got some environment variables being used in the web app at the top to basically talk to the database. But do note here, effectively this idea of ports is appearing again, right? So we're basically saying port 5000, 5000. We're saying actually take our port, which is 5000, expose it to the outside world on 5000. If you look at my GitHub, you'll find a very similar, you'll find the same code base used in an Nginx demo, and you can see their Nginx being used to actually put out on the port 80 or port 443. So, but here we're just doing that. Okay, so quickly we'll run that. See if it works. Right. So I think I built this one earlier so that it's quick. Okay, so just spinning up basically that web, and effectively it's making sure that the database is up to date and it's listing. And as you can see at the bottom, I don't know if you can see that or not, but it's saying now listing on HT 5000, right? So essentially we spun up our app and it's now listing on a port. We can demonstrate it works. Going down here. We can call it. So this basically, there's an extension of Visual Studio Code that lets you basically take files with an HTTP extension. It's called REST client, I think, and it actually basically file requests. So this is a file request basically at that port, and you can basically see I've already done one earlier, or I can post another one here. Whether it's hello world, so when I basically get the whole list of them again, should be 2 in the list, and I think I've got some down here. Let's create a hello Alice, and effectively you can see that one there. You see hello Alice is popped to the top of the list, and you should better see some output from ASP.NET. Basically, it is getting hit, right? You can see that's really right. Okay. So what we're trying to demonstrate there effectively is just that we are essentially saying, hey, we're going to run a service and we're going to listen on a port, we're going to take traffic on a port. That's something you do every day, right, probably? But the key idea is that we're essentially something that's self-hosted. We're in kind of like a console app. We just spin it up and we start talking basically over a port as opposed to basically kind of some kind of IIS hosting. All right. And we'll dig deeper in the second half after pizza.
Pizza downstairs.
All right, welcome back. Let's talk a little bit about processes and concurrency. So one of the other statements in 12-factor apps is to execute the app as one or more stateless processes. Does everyone kind of know what we mean by stateless? So this is a really odd word, right? Because really we kind of mean state aware, because no one's saying your app essentially doesn't ever use state. It's just saying that effectively it needs to discard that state essentially and load it with each basically request. So you basically need to avoid things like sticky sessions. You basically destroy everything in the backing store, etc. Right? And the reason is you can't guarantee that that machine is essentially going to exist between invocations. Because if I want to create an elastic on-demand architecture, I'm going to need to be able to create machines to bring them up, and I'm also going to need to bring them down overnight. And if I have machines which must exist, then I'm not going to be able to do that, right? So anything that's essentially sticky prevents me from scaling properly. So you can potentially we're talking about basically this idea of effectively saying, don't trust anything that's not basically provisioned backing service. There is a kind of exception, which is to say, if between the request coming in and me giving the response, I want to temporarily use, memory or the file system, that's fine, because essentially if the machine goes, I've lost the request anyway. Just you can't use it longer than that kind of period. Different process. So we talked a little bit about this idea, basically saying HTTP listing on a port. Please remember there are other workloads, right? So, and we may want to basically you probably want to give every single app one kind of workload, right? So this thing listens essentially to HTTP and does work. This thing listens to AMQP and does work. Because anything that's running effectively on a different protocol, it's on a different port, is probably likely to need to be scaled independently of each other. Okay, it's about offloading work. So the classic scenario is that during any given lifetime of our application, it may experience a peak of demand. Classically, Huddle, for example, has its biggest peak of demand at between 2 and 3 in the afternoon. Does anyone know why that would probably be?
What is Huddle?
So Huddle is essentially a SaaS business where you act as an intranet and extranet for you. Think of it as SharePoint in the cloud.
US time zones, morning, starting work.
Right, exactly. So basically that's when the US starts work. We already have UK customers online and the US begins to ramp up. So between 2 and 3 is our peak demand period. So at that point we suddenly get a lot more traffic. Okay. And the problem with essentially that kind of demand is there's you could say, I'm just going to scale up more web servers to deal with that, all right? But actually, sometimes there are other easier choices. Sometimes you can say, do I need to actually do all of that work immediately? Or can I actually offload some work? One of the problems with me just reaching for the solution immediately is saying I want to scale up my web servers is that actually they may not be the bottleneck, it might actually be my database. So if effectively I'm using an RDBMS, essentially I'm not effectively therefore got distributed state, not just like Cassandra or whatever effectively. My problem can be, even if I've got, paid for some really expensive version with some read-only stores and always on, and I've got budget coming out of my ears, but essentially my database will ultimately be the bottleneck, right? And so actually increasing the number of web servers just basically flushes my problem downstream. What I want is some way of effectively throttling my access to that database so it happens at a controlled rate. Generally, when we look at this, one of the things we also tend to talk about is how fast does your API need to respond? Now, a reasonable rule of thumb is somewhere between 200 to 300 milliseconds is what you should be aiming for an API request. At that point, probably your web server will continue to basically serve requests as fast as they are effectively incoming, and you won't essentially get queuing on the server. If you get queuing on the server, that essentially means it can't handle the requests with a number of threads available on the server, and essentially you get backing up, it queues a certain number of requests, and then basically users start to get a yellow screen of death, right? Essentially it starts rejecting their requests right at the outskirts of the web server. So you don't want that to happen. Okay? So again, if you have long-running pieces of work, the problem is that long-running piece of work chews up a resource, right? Effectively a CPU on your box for a long period of time. Essentially, while it's processing that request, nobody else can get in. So it isn't just that it takes a long time for the user to receive the response and the user goes, this is really slow. It's that you're taking a shared resource, which is essentially the CPU on that particular box, and you are hogging part of it, which just reduces the throughput of everybody else in the same box. So if you have a long-running request, it's really important to say, I don't want to basically have that. I don't want to deal with it. Right? So what do you do? Generally speaking, what you would do is you'd say, right, okay, rather than effectively dealing with your request directly, I'm giving you a 200, or I will basically give you a 202 acceptance and say, I have your request, but I'm not going to deal with it right now. Oh, by the way, in my link header, I'm going to give you a link to URI. You can go to that URI, and that is a progress endpoint. On that progress endpoint, I'm going to let you monitor your request. Now, either you're creating something, and essentially you're expecting to see the resource when you're finished, in which case maybe I'm just going to give you a 404 on that link endpoint until the resource actually appears, in which case I'll give you the resource. Maybe it's not actually a single resource that you're creating, it's some kind of bulk operation, in which case maybe I'm going to give you a status indicator of how far through the work I am and what's been completed, and you can actually poll that endpoint to see the progress, and at the end of it, maybe I'll redirect you essentially to something because the task is now done. Okay. So where does that work go? Right. So one option people often reach for is, oh, I've got some kind of background worker process on my box, and the answer is that's still using a thread. See, I'm still chewing up resources on my web server, and I really wanted to offload it. The other option is kind of like, oh, I'm in some kind of, doesn't async solve this problem for me? And the answer is not really. Async essentially decreases the throughput on the box, but it's not going to solve the problem on the back-end database server, right? So what do? So you can choose a message queue. It's called a task queue. And essentially you say, take that work and put it on a queue. The queue guarantees to me, if I basically set up my queue so that it's durable and have guaranteed delivery, that I will not lose your work. Okay. A consuming service will consume from that queue, but I can now throttle incoming work, so I can do it at a pace that essentially allows my database to cope with the load that I'm putting on it. So the queue helps me basically smooth out peaks and troughs in demand. So I get a nice, smooth, even supply of events to my back end. And when the back end completes, it probably just basically updates effectively a status table inside my database, and then the polling service at the far end goes, oh yeah, I'm done, right? And even better, I'm probably not, potentially if I want to, I'm not polling. I also give you as a link, potentially, when I give you my 202, I may give you something like a signal R endpoint, so effectively you can subscribe to a push notification notify when it's done, and then I'm offloading your polling off my server as well at the same time. The approach is called a task queue, right? Who's ever used a task queue before? Okay. So in the web world, there's some really good academic papers about task queues, and essentially there's a whole lot of papers that essentially say, you can build your async architecture, you can go and build your web server effectively that says, hey, effectively I'm going to use kpoll or select, and when the request comes in, basically I know that basically I can just say, I'll service another request until the I/O completes, and I'll rotate the thread back, and one thread, hey, Node.js can service whole loads of things. You cannot get anything like the same performance benefits you can get as using a task queue. Just can't do it. This is the best way to do it. So if you lived in the Python world with something like Django, anyone ever done Django development or anything like that? Okay. So in the Python world, you probably know something called Celery. Celery is basically, if you are a Django developer, you've probably got basically a toolkit called Celery, and you use Celery basically as the task implementation. Effectively, in your Django site, you tend to offload the running work via Celery basically to a queue that runs a back-end process. Okay. I think there may be an equivalent on Rails, but I can't remember its name. And there's an equivalent on Node.js called Seneca. So Brighter basically does this work for you on .NET Land. Right? And you can also use things like Mass Transit and then Solus Bus to do the same piece of work. With a kind of big three. All right. Let me show you how this works. Has Matt gone to fix the app now? I've explained to him how it all works. And then, just because when you shift branches in Visual Studio Code, you don't restart the IntelliSense; it all goes horribly wrong. No, it's still going to be wrong. Let me. No, hang on.
So you use competing consumers if one of those tasks takes stupidly long.
We're coming to that later.
Sorry.
We're getting ahead of the application. That's the big reveal later.
I was saying.
You ruined the magic trick.
Should I do as well?
Okay. Code does this sometimes. I don't really understand why, and it kind of like says, I've switched, but I'm not going to show you the code that lives in here.
You should use Rider.
So again?
You should use Rider.
I could do. Should like me to. Rider's not so good, basically, at being visible on a small screen. I think it's that problem.
This is presentation mode.
I haven't played with this presentation mode yet. Right. Let's see if there's a.
There's a reason I'm not selling it.
Why will you not give me a piece of code? Right. Just bear with me while I. Remember that? Okay. So there's a program.cs is there, and yet good old Visual Studio. There we go. Right, okay. The Greetings Worker is the bit we didn't show you last time, right? So Greetings Worker effectively is now the console app. Now this looks a bit complicated. We do have a better version of this now, which relies, so I don't know if you know, but the .NET team introduced something called hosted service. So the way that effectively we build a ASP.NET app with a console is to use the web host builder. Okay, and then there is in the startup form for this. This bit of code that gets called that essentially gives information on the hosting environment and gives us information. Lets us basically do things like add to the its IOC containers. Actually, you've all seen that before. So there's a version now that which you can use basically for console applications that are essentially non ASP.NET based. We now have a plugin for Brighter, which works in the same model and essentially simplifies the config. But okay, so the config here looks very simple. Basically, we're creating a thing called a dispatcher. So a dispatcher in Brighter is just essentially a one or more listeners that listen to a given message queue, pull messages off that queue, and then essentially dispatch them to a command handler. So all you have to do is write your handler and hook up essentially some config that says, when you listen to this queue, you'll get a message on that queue directed to this handler. Okay. And so that's the dispatcher being spun up basically and working. This configuration is effectively what we have a slightly better version of now, which is essentially you can ignore the logger stuff. But what we're going down here essentially is the same as dispatcher. We're effectively creating a subscriber register saying we're going to get a command that's going to go to that command handler. We've got some retry policies, so we use Poly. Anyone heard of Poly? Poly is a library that lets you do things like retry and circuit breakers. In other words, basically gives you some reliability about services. So we let you plug that in and use policies. And essentially this dispatcher is basically the core of what we're doing. Essentially it's saying it's going to listen basically to a given queue with this given routing key, and we're going to effectively listen to those messages and dispatch them to a handler. And the handler will be in here. That's another one that doesn't show up half the time because, oops, I think I'm overcompensating because the small size of my screen and I kind of miss everything. And it's like when I drag the scroll bar, it jumps across everything. So it's just a bit of a pain because I feel like a clumsy giant right now. But the regreet command handler is here, and this is the handler that basically gets called in response to the message. And it's just going to say, effectively, go and get the greeting out database and write some console screen. Now, generally what we would say is if you're talking about kind of microservices architectures and isolation boundaries, that your task queue separates effectively two processes that are part of the same app, and they can essentially talk to the same database and they can share the same model. You're just literally using a distributed architecture, but you're not necessarily using a service-based architecture to separate those two items. And the advantage of this kind of model of everything being a handler, well, one is from your point of view simplicity. You're just writing handlers for commands everywhere, right? So you just keep, so all your developers have to do is just say, I'm going to create a command, I'm going to write a handler, I'm going to register that handler essentially. You don't have to deal with any of the underlying queue infrastructure, right? And we also, the app will do things like create relevant queues for you, etc. And it's pretty good now in the current version at dealing with things like network partitions and restarting and reconnecting for you. But one of the things you're trying to achieve, and to some extent up here, inside the handler over here, I think it's add greeting, does it? We'll see in this version of add greeting, yeah. We just basically use it, so rather than do command processor send, which we call basically send the command to a handler synchronously, we just do post here. And post says effectively do that asynchronously, send it over a message queue to the other side. People sometimes ask about why send, post, why does it make any sense? That's because that terminology comes from the fact that I'm a age-old COM programmer back in the day, and the way we build Brighter works a little bit like a COM, basically single-threaded apartments, which basically were a way of doing inter-process communication using Windows message pump. And you could send to be synchronous and you could post to be asynchronous, so that's where it comes from. And that most of you have probably dealt with that at some point in life without realizing it, because you've added an attribute called STA thread to your main without knowing what the hell that was for. When you've been doing Windows Forms programming and the like, and that simply means single-threaded apartment. And all that just means there's a message pump here, right? A little bit of historical fact, you need to know that. So that will essentially post a message across. Now, a couple of things we might be useful to see. I think this is up. So This is a management console for Rabbit, which is basically the message queue we're using. And you can see essentially there is a lovely bring request in there. I don't think that's this one. I think we're going to get a different queue. So Rabbit consists of a number of exchanges. Those exchanges basically hold queues. You can also see people connected to it, etc. Right, so we'll come back in here in a minute. We'll see some stuff inside it. So we need to do a couple of things to get this working. The first thing is we need to actually build it. And we need to hope I don't need an internet connection. Build.ps1. Come on. Have I not done up here? Build.ps1 on this version? Because I assume that I'm basically inside Git console. Okay. Let me just quickly switch shells. Why did none of you warn me? Come on, where's your pair programming skills? Are you not agile? Okay.
We're using this way.
Yeah, thanks. Come on. Dot / build message.
I was just about to say
All of that.
yeah.
Not on the interwebs.
No, it doesn't look, it's not on the interwebs. We've got an internet connection tool. No?
Wi-Fi guest. I can't remember what the password is.
They've just changed it. Be our guest, I think.
Yeah.
VR guest.
Be our guest. Be our guest. One word, lowercase.
Yeah, I can imagine.
Has anyone actually ever say no? No? So disconnected? Let's try. The best thing about being a software developer and using things like GitHub and NuGet is when they say stuff on like trains, like etc., make fair use of this service, and they block stuff like YouTube, etc., because they think that's going to be unfair. None of them ever think to themselves, we must block GitHub and NuGet too before everyone basically downloads stuff off that. Right. Okay. That should be good. And if we're lucky, this will actually run. That's because basically I've got Rabbit running already. I think.
Kill everything.
Cool. Clear that. I'm assuming none of you are that worried about seeing esoteric Docker commands, but I'll clear it anyway. Right, so if we look at compose, we'll spin up basically. So in addition to a web app in our database, this time we're going to spin up basically a worker. Right. And so this is basically spinning a bit. Okay, so one of the things that you need to be aware of when you are building apps that depend on backing services, particularly in this kind of environment, is your backing service may not be there. Okay. So when you spin up your service, there's a common pattern we tend to do is kind of like, oh, spin up my service, I'll start talking to the database, and how do you know your database is there? Right? And so you tend to have retry loops, which basically say, I need to sit here waiting until effectively I can connect to everything that I belong to, right? So we quite often have a thing like a short database in a console on a web app, which basically says, is there a database that I can find and I can talk to? If not, there's no point in me going much further as an app, and I'll eventually shut down after a certain number of retries, right? So everything in your environment is now ephemeral. It may no longer exist. So one of the things that Brighter will do for you is do that. It'll basically say, I need to talk to these message queues. I'm going to keep retrying for you until it appears, right? Because maybe you've just lost the cluster and you're basically waiting for it to come back up. So that's saying circuit broken. Still not talking to Rabbit. Why am I not talking to Rabbit? Why don't you want to talk to Rabbit? Are you just waiting to retry? There's a waiting regret command. There is basically a thing there, and it's saying I can't talk to Rabbit. All right, let's try. Starting that. See if it gets happy. We'll try again. So a broken circuit is when essentially we try and talk to something, we fail enough times, and we say, let's break the circuit. Let's stop trying to talk to it, and eventually every so often we'll let a request through as a test, and if basically it succeeds, then we'll then basically let everybody back in. Okay.
Doesn't look like Rabbit started.
Yeah, it seems a little bit unhappy, doesn't it? I think probably
It
why.
is.
It's running there.
It shut down nice at that time as well.
Yeah, it seems to be unhappy, doesn't it? Application needs to start. Oh, it started basically.
Yeah, I think you actually killed it a bit prematurely now.
Yeah, I thought someone said to me to kill it. Who is that?
Turn it off and back on again.
Yeah, right. You're absolutely right. Yeah. It eventually would. I'm just trying to short circuit the process of it getting into a broken circuit loop and then taking quite a while before effectively we spin up, because it'll effectively wait increasingly longer periods for you to basically enable the Rabbit cluster, and we might be here a while. Correct connection pool.
There you go.
Set to MQP connection. So that's Rabbit started up and basically put its plugins, version management agent, and everything else. So Rabbit is now running.
Are you logging success things to the console?
We should do, yeah. You should see basically it telling us that it's starting up a number of listeners. But this is just Rabbit running. It's not actually our app running at this point. Oh, that's crashed.
I think the app started going to a poly retry loop and then it succeeded and hasn't really done anything else since.
Yeah, but so it doesn't usually fail quite like this. It suggests there is something it's not happy about, right? Just to just check there's nothing spurious running out there. Right, let's try again. Right, that's talking to the database. And that's essentially a health check while trying to talk to the database, basically to say the database up, because MySQL takes time to start up, right? Starting the broker. So we've got a dependency in Compose that basically says start this after this, but of course starting something doesn't indicate that any of the services basically are working. So one of the things is we're trying to enter a link to say, are you working and are you willing to receive requests? However, that's usually the end of the process, so that may be that it's kicked itself into life and we did a down and restart. Okay, let's have a look. Okay, we have no queues, which is not a great sign, because we create a queue automatically. So the fact that there's no queue there suggests that we are not where we think we are. Do I have a worker process running anywhere? Right, worker. What happened to worker? Should be a worker process in the compose file.
Is that not a call stack saying the work process didn't start?
Just trying to figure it out, yeah, trying to find the call stack for worker. Where do you see that?
Yeah, there you go, there, yeah. Keep going down.
You can't connect to SQL Server.
Crashes by the looks of it.
Yeah, but that's basically that's an ensure database loop, which I think is fine. I don't think that should have died like that.
Check the running containers.
Yeah. Alright. I'm going to have to probably move on because I'm going to have to catch a train at some point. Okay, I'm not sure at this moment why that demo is not working. The difficulty a little bit is, so I'm going to spin it up again in the background, put a -d on it and let it just basically not go to the console, and I'm going to move on with the rest of the talk and come back and have a look and see how we are for time at the end of the day. That demo. Okay. So all you're doing this is that basically it picks up the message off the queue and essentially prints out to the console. And I don't quite know why that demo is failing there. Okay, let's move on with this and then we'll come back to that. We have got time. Ironically, maximum robustness is fast on my base of shutdown is my next slide. I'm being trolled by my own slides. So you're going to start for shutdown with a moment's notice. So obviously, basically, if we've got elastic scalability, there's no point in us having the ability to say I want to create basically new instances in order to cope with demand. If actually it takes half an hour to do that, right? There's no elasticity in that. So we start in a few seconds, stop gracefully. So when we stop, basically you usually get a couple of choices on any kind of service, right? One is, do I basically just terminate abruptly, or the other is, do I run out existing jobs? So there are trade-offs, right? Running out existing jobs is nicer because it essentially says, I'm not going to effectively abandon some work. But of course, if that takes a long time, then the problem is essentially because it takes quite a long time to actually shut your service down. And that it's hard sometimes to distinguish between long time to shut your service down and it's not responding to my shutdown request. So Brighter effectively will run out your jobs because it's trying to be friendly and it says, I will basically run your jobs to completion, but I'll take no new work in. Right? So basically it cuts off the input pipe and then just runs out any jobs that it has and then restarts. In theory, you could kill the process talking to a queue, and eventually because you never act the message on the queue, eventually the message queue will make it available again after a window expires, right? Request on your front end, obviously, if you terminate abruptly, what happens is that your users basically see interruption basically to their request, but it's harder there to really get control of what's going on in something like Kestrel and say, don't take any new input requests and just run the old ones out. But something like Nginx can do that for you, right? So you put Nginx in front, Nginx will let you basically terminate existing web requests and refuse new ones. Scope by the process model. So essentially, prefer to use new instances of the process rather than threads. Why? Well, essentially, in most models, it's hard for us to monitor an application essentially and say, oh, introduce new threads into the application, right? Generally, monitoring tools don't really work that way. It's not very effective. It's much easier for us to simply monitor the application and spin up a new process instead. Think of it from a point of view of ops. If I'm automating something like an Amazon CloudWatch alarm, what I can really see is the queue's building up. I'm going to introduce a new process. it's much harder to say the queue is building up, add an extra thread. So Bright will do, for example, will let you increase what we call the number of performers, which essentially is the number of threads processing a given queue. But it's very hard to understand how to do that at runtime in response basically to something like a queue building. It's much easier just to simply kick off a new instance to help you do the work. Okay. That's what, so processes we share nothing. I stateless, and then you can cast away and introduce new processes. The last point's really probably not that relevant, but basically don't rely on things like Windows services and daemons. Rely on process managers like supervisor D instead. So as mentioned earlier, if my queue, if essentially once I put things on my queue, actually a single processor is not processing as fast as database can handle, what I do is scale up the number of processes. I input what's called a competing consumer model, and I have more than one process reading off the queue. There is one reason why you may not want to do that, and that's ordering. Okay, if you want to process in order, you can only ever have a single active consumer at one time. If you have multiple consumers, they will begin to process out of order, because if the queue is in order, there's no guarantee they're going to read basically and process those items in order. Generally speaking, if you want robustness, what you tend to have is a hot standby, and both of them effectively take a distributed lock somewhere, and they say essentially, am I the leader, etc. And if so, I'm processing requests. If I'm not the leader, is there a leader? If there's no leader and I'm not the leader, I should become the leader, start processing requests, right? So you have a hot standby, but otherwise, essentially, competing consumers help you process the work in the queue when it builds up, but at the cost of ordering. Okay, build and release. Generally, so the idea effectively is you put an app in one repo, everything lives in the same repo, right? Even if you've got multiple services. Share code should be manage share code not by shared repos, but basically by some kind of package manager system like you get. Right. Treat your own internal packages as exactly the same as you would NuGet packages. Sharing code repositories gets you into all sorts of problems because there's no built mechanism for versioning your dependencies. And deploys a running instance of the app using the repo. So there's a goal which essentially says, in Tabletop apps, what I do is I go git clone the repo, and inside there is some kind of build, shell script or PS1 that essentially I run, kicks off and starts running my application for me, basically, right? And the idea is to basically minimize the startup time for new developers to your team. Don't force them to basically go and grab from 20 repos, figure out basically you've got some Git sub-repository tree, basically launch some Byzantine process to build configuration and template files, and after a week they finally are up and running with your system. Yeah. Okay. Isolate dependencies. What do I mean by this? So essentially the idea is I create a new machine. It's basically cattle, not a pet. I effectively install the OS on it, and then basically what I want to do is deploy my app on it and have my app pulling dependency down it needs onto that machine via some kind of package manager. Okay. So Python has basically pip, an isolation by virtual env, Ruby gem files, and actually .NET's got quite a good model basically with the packages basically directory and NuGet basically, and essentially you be able to put your packages inside your CS proj file, right? So it's pretty good. It especially declares the dependencies, and you can pull them down by .NET restore, essentially the machine. Config, still config in the environment. There's a bit of a thing on this. Essentially, you may not have a file system that you can rely on, particularly effectively in an environment like serverless. So we don't want to put your stuff in your config file. But more than that, essentially, you don't want to hard code locations into a config file, because you're running in an environment where things disappear and come back all the time. If you need to find something, then you need some kind of centralized service like console or some kind of service mesh that lets you say, where do these things live? Please tell me where it lives, and I can go and get it basically and talk to it, right? So DNS records, whatever is appropriate. But don't hard code things into your config file. Environment variables are a very common thing that 12-factor apps used to recommend. Put all your things in an environment variable, and then essentially you can effectively ingest the environment variables basically in apps and will talk to the location. People don't tend to recommend that as being realistic anymore. There are two reasons. One is essentially that your environment variables will effectively, during a crash dump, will basically be displayed to everybody. And if your secret passwords are in there, your developers now know all the secret passwords. But two is it's exceptionally hard to manage basically huge numbers of environment variables across fleets of machines. So you tend to rely now on key value stores like Zookeeper, Console, etcd to basically store the locations of the services that you need, right? So that tends to work today. Separate build and run stages. So essentially make sure that you understand that you have some things that basically you do to build and you have some things that you do to run. You can do them entirely separately, right? Don't combine them all into one big script. And any release is a combination of the build and the config for environment. What we mean by that is, don't force me to basically rebuild the software in order to deploy it to a new environment because it requires new config. Right? My release artifact should be immutable. And when I deploy it into that new environment, it just basically picks up on whatever the configuration is in that environment. Okay. And it just really has to do with the nature of cloud or container-based environments. Things are ephemeral, and essentially you can't rely on hard-coded config strings anymore. All right. So these basically are the 12 factors, and we'll just run through them as the kind of summary. So one, code base tracks and revision, control, manage, deploy. So that's really just about saying, have it in one Git repo. Basically declare and isolate dependencies. That's in other words, basically when I deploy into the machine, any dependencies that I actually need should be essentially something whereby a script can go and pull them down onto that machine and generally package with my code, right? Some kind of package management situation. Store config in the environment, and that's really just saying don't hard code basically your connection information into a file-based config system. It does not scale. Treat backing services as attached resources. Remember that anything you talk to in these kind of environments is ephemeral, including things you may have depended on previously like file systems and caches. Treat separate build and run stages. In other words, essentially have separate scripts to do both because they are entirely separate operations and you want to basically release immutable artifacts. Execute the app as one or more stateless processes. In other words, basically we don't want to have state because state means that as a machine that I cannot take up or take down on demand. Exploit services via port binding. In other words, basically the easiest way to deploy yourselves into these kind of environments is simply to have a standalone process that listens to or reads from a port. And then essentially the hosting environment, be it Kubernetes or your cloud, etc., deals with basically sending messages to and from those ports. Scale out with the process model. In other words, it's easier for us to basically use automated tooling to scale out our system if we are able to introduce new process instances rather than basically worrying about threads. Maximize robustness if I start on a graceful shutdown. That's what I was doing earlier. But essentially, make sure that essentially in order to be elastic, I can spin up an instance quickly and I can take it down quickly so I'm not either A, paying unnecessarily and not able to unreact to demand. Keep development staging and production as similar as possible. These are the three we talked about. Essentially, not only is that, make the environment as similar as possible to avoid mistakes where I'm using basically entirely different database systems in different environments, using SQL Express here or an actual SQL server out in the production environment. But also it's about not having too great a time lag between the code which basically the developers are dealing with and what is deployed to production. Because it's hard to reason about what's happening in production. If you're 6 months, that's what you were looking at 6 months ago in your code, you've got no idea what the production system does anymore. Was that bug fixed? When do we fix it? Right? Treat logs as event streams. If you don't have a local file system, you're not logging to a local file system anymore. Essentially log to something like console and then use something like Kibana to collect your logs together by basically a beat. Your problem is essentially, particularly in microservice environments, that you're not going to go to all those machines and try and gather all the logs into one place. You're going to need to use tooling to do that. Run app and management tasks, and one of the processes is a fairly minor one. It just says, if I have tooling that helps me manage that service, put it in the same repo as the service. And partially that's because otherwise developers basically change the service and they break basically all the tooling because they've forgotten that there's tooling that's dependent on the service working a certain way. Okay, that's that. I probably need to not take too many questions nor run away. I will figure out what is wrong with the Rabbit demo. I noticed earlier anyway that I'm using a slightly older version of Brighter. I don't want to fix it before today. So he's looking at me at some point and I'll address it and then you can go and run it. And it's fairly easy to run. You just basically need to build it, run Docker, and then you can go in that test HTTP file and basically run the create post and you'll actually then get something going out over Rabbit to the far end. All right, thanks very much.
Thanks a lot, Ian. Really enjoyed that talk. He's got a train to catch, so